Okay, so this is the review for the Liberal Arts Math 2 test that is going to be on Monday the 15th. Even if you are not here the day before, you still have to take the test if you were here. And if you're absent, they'll do makeups. If you miss the makeup, you get a 0, okay, on your test. That's kind of a big deal. So make sure you're here, make sure you're on time. I'm not sure if we're testing in here or in the media center. I will let you know on Thursday. If you're not here, I will hopefully try to remember to post it on Edmodo. Make sure you're paying attention, listening to announcements, listening to teachers who are calling people up to test, etc., so you know where to go.
Are we going to test in the morning or at night?
I have no idea.
I got it.
All right. On the first one, consider the function f of x equals x times x squared minus 4 times x squared plus 9. What are the real zeros of the polynomials? Okay, since it's already in factored form, it's actually pretty easy because it's in factored form. If it wasn't in factored form, we'd have to go about some other way. But since it's in factored form, I can set each factor equal to 0. So x is a factor. Set it equal to 0. X squared minus 4 is a factor. Set it equal to 0. And x squared plus 9 is a factor. Set it equal to 0. Okay? And then I'm going to solve for x for each one of those, see which ones are real solutions.
They said something. Right.
So here I've solved for x. So 0, is that a real solution? Can your graph cross the x-axis at 0? Yeah, so that's a real solution. That's one of them. Here we'll have to add 4 to both sides. So x squared equals 4. And then since x is being squared, we'll have to take the square root of both sides. Make sure you take the positive and negative square root of 4. Square root of x squared is x equals, what's the square root of 4? 2. So we have a positive 2 and we have a negative 2, right? Can your graph cross the x-axis at positive 2 and negative 2? So those are two more real solutions. Over here, we'll subtract 9 from both sides. X squared equals negative 9. Take the square root of both sides. Make sure you take the positive and negative square root of negative 9. Square root of x squared is x. What's the square root of negative 9?
Negative 3.
Nope. What's the square root of 9? 3. What's the square root of a negative? I. Right? So this would be positive 3i and negative 3i. Is that a real solution? No. It's two solutions, but they're imaginary. If the question said list all solutions would be 0, positive 2, negative 2, positive 3i, negative 3i.
Negative 2 and 0
and positive 2. Yeah, because it says all real, it says what are the real zeros? Zeros are the same thing as solutions. It's the same thing as roots, okay? So 0, positive 2, and negative 2, which would be B. Number 2, what are the roots? Remember, roots is the same thing as zeros, as solutions. So the first one says, what are the zeros? The second one says, what is the roots? It means the same thing. What does x equal, basically? What are the roots of the polynomial equation? F of x equals x cubed minus 2x squared plus 9x minus 18. So on this one, is this a quadratic where we can try to factor or use a quadratic formula? No, it's a cubic, okay? We only know so many ways to solve this. And since it's not a quadratic, what we're going to try to do, and I've shown you all this before, but we did not work a lot on it, is I'm going to try to see if I can factor it by grouping. And if that doesn't work, we're going to have to try another method, okay? So factor by grouping means I'm going to group my first two terms together, and I'm going to group my second two terms together. And I'm going to take out a GCF of each group. So what's the greatest common factor of my first group? X squared. Alright. So to figure out what's left in parentheses, I divide just the first two terms by x squared. What's x cubed divided by x squared? X. Negative 2x squared divided by x squared. Negative 2. In my second group, what's a GCF? 9. And whatever the sign is of that first term, that's the sign I'm going to take. So I'm going to divide out a 9. What's 9x divided by 9? X. And negative 18 divided by 9? Negative 2. Now, if what is inside parentheses is identical, then this way will work. If it's not, then it won't work. Okay? Danielle, can you bring me that phone, please? Bring that up here. So since what's in parentheses is identical, this method is going to work for us. So what you do is, we're going to factor out x minus 2. No, you can bring it up. So x minus 2 goes in one set of parentheses. Whatever is left here on the outside, you group that together in the other set of parentheses. And I did not break it, right? So if I FOILed all this out, x minus 2 times x squared plus 9, I would get what I started with. Basically, I factored it. But I haven't found the roots yet. Okay? I haven't found the solutions. Once I've factored, I can set each factor equal to 0 and solve for x. Okay? So now I'm factored. I'll set x minus 2 as a factor, set it equal to 0. X squared plus 9 is a factor, set it equal to 0. And then I'll solve both for x. So here I'll add 2 to both sides. X equals 2. There's no square roots or anything like that because x is not squared. Then over here I'll subtract 9. So x squared equals negative 9. And I will take the square root of x squared and the positive and negative square root of negative 9. What's the square root of x squared? X equals positive, negative. What's the square root of negative 9?
3i.
3i. Did the question only ask us for real roots?
No.
No, it says what are the roots? That means real, imaginary, everything.
It's D.
So I have 3 solutions. 2, positive 3i, and negative 3i. So yes, it is D. So pay attention what it's asking for. Does it want everything, real and imaginary? Does it just want real? Number 3. What is the result of the polynomial in long division? Okay, we haven't done this in a while. No, it's long division. Alright, so they're taking this term, our numerator, divided by our denominator. So the denominator is the divisor. So that's what goes outside of your division bar. And then your numerator goes under. So 2x cubed. Remember, if you're missing any degrees, you have to put in a placeholder. We're not on this one because we got 3 degrees, 2 degrees, 1 degree, 0. So we're not missing anything. If you have forgotten your long division, remember when we did long division, I posted a video on it. It's in your notes. So if this one doesn't remind you, you need more help, go back, look through Edmodo, find that video, find your notes, go back through it. I guarantee there will be a long division problem on there. Okay? So remember, we look at our divisor. So x times what is 2x cubed? 2x squared. So since it's a squared term or quadratic, we're going to put it above the quadratic because everything needs to line up. Helps us know if we're off somewhere. And then we multiply. What's 2x squared times x?
3x squared.
2x cubed. If these two aren't identical, then we did something wrong. Okay? Then we multiply 2x squared times positive 1, and we get 2x squared. And this is where we draw a line, and we change the signs of both of them. So positive 2x cubed will become negative 2x cubed. Positive 2x squared will become negative 2x squared. 2x cubed minus 2x cubed is 0. And then what is positive 4x squared minus 2x squared? 2x squared. And then that next term, we're going to drop it like it's hot. And then we just start all over again. So now instead of saying x times what is 2x cubed, you say x times what is 2x squared. We're going to look at our new polynomial. 2x. And would that be positive or negative? So we put a positive 2x. That's a linear term. We put it above the linear term. Then multiply. 2x times x is 2x squared. If these aren't identical, something's wrong. And then 2x times positive 1, we get positive 2x. Same thing over and over. Draw a line, change the signs. So my positive 2x squared will become negative, and my positive 2x will become negative 2x. 2x squared minus 2x squared is 0. If it doesn't cancel, something's wrong. What's minus x? Remember, that's a minus 1x minus 2x. Minus 3x. Start all over. X times what is negative 3x?
3.
Negative 3.
Don't we have to bring the 1 down?
Oh, yes, thank you. Forgot to drop it like it was hot. Good job, good job. Bring that 1 down. So negative 3 times x is negative 3x. If these aren't identical, something's wrong. Negative 3 times positive 1 is negative 3. Draw a line, change the sign. So negative 3x will become positive 3x. Negative 3 will become positive 3. Negative 3x, positive 3x cancels. Notice every time they cancel, if they don't, that lets you know something's not right. And plus 1 plus 3?
4.
Is there anything else to bring down?
No.
No, so that's my remainder, and it is positive. So you write that as, we're looking for 2x squared plus 2x minus 3. We've got one here. And just to make sure, 2x squared plus 2x minus 3, we add, the remainder goes on the numerator, the divisor goes in the denominator. If they don't put remainder 4, then it's going to be written like this, okay? So yes, option A. They can write it either way. Probably you're going to see it written like this with a fraction on the end. Yeah.
Do you know if they're all multiple choice or not?
No, they're not all multiple choice.
You have to put in some numbers too.
Okay, so also, if y'all remember, if we have a remainder, does that mean x plus 1 and 2x squared plus 2x minus 3 are factors of 2x cubed plus 4x squared minus x plus 1?
No.
Are they factors? No. If I multiply these together, I'm not going to get this because I have a remainder. If I didn't have a remainder, then those two, the divisor and the quotient, would be factors of the dividend. But they're not, if I said that correctly.
Dividend.
All right, number 4. Consider the intersection of the functions. X squared plus 2y minus 4 equals 0. That's a parabola, right? Its highest degree is 2. So we know it's a parabola. Terrible looking parabola. It opens up because A is positive. And x plus y equals negative 10. That is a line. X's highest exponent is a 1. If we put that in slope-intercept form, be y equals negative x minus 10. Your y-intercept would be negative 10. Your slope would be negative 1, right? So I don't know. We would have to graph them to see exactly, but they're going to intersect in possibly two places. Let me pause this. Okay, so in this problem, they want to know, it says consider the intersections of the functions, so that means where they cross. It's worded kind of weird, okay? What is the greater of the x coordinates of the points of intersection? So they're saying basically, it's going to cross two places, right? This is an ordered pair where it crosses. That's a solution. This is an ordered pair where it crosses. That's a solution. They both have an ordered pair, x and y. It wants to know, of the two places it cross, which x is greater, okay? It's not multiple choice, so we can't just plug numbers in and try to guess like that. We actually have to figure out where it crosses. We took notes recently on systems of nonlinear equations. I don't know if y'all remember that, but we took them recently. If not, there's video on Edmodo. So all you have to do is take these two equations, okay, and you can either isolate the x in both of them or isolate the y in both of them. It doesn't matter, but you have to isolate the same variable in both equations. So I just chose to isolate the y. I'm going to kind of do this here and then I'll do more work over here. So let me take x squared plus 2y minus 4 equals 0. I'm going to isolate the y. So if I want to get y by itself, I chose to subtract x squared from both sides and then to add 4 to both sides. So that gets rid of those two. I'm left with a positive 2y equals negative x squared plus 4. And then y is still not by itself, right? So I have to divide every term by y. By 2. And that gives me y equals negative, you can do x squared over 2 or 1/2 x squared, it doesn't matter. I'm just going to do, for now, negative x squared over 2. And then plus 2. I haven't solved anything yet. I just took one of those equations and isolated the y. That's all I've done. That's what I did with this quadratic. Now I'm going to take, listen, I'm making a recording. Now I'm going to take x plus y equals negative 10, and I'm going to isolate its y. So this one's easy. I'll just subtract x from both sides, and I get y equals negative x minus 10. And the reason we're doing this is because we want to find where these two equations are equal, okay? So we want to find when their x is equal to the x and one, and where the x and the y in one equation is equal to the x and the y in the other one. So to do this, if we isolate the y's, whatever the y's are equal to, set them equal to each other. Peter, bring me your phone. Second time, bring it to me. So I'll do negative x squared divided by 2 plus 2 equals negative x minus 10. See, notice how I only have an x in my equation, right? I only have an x there. So I'm going to try to get x all by itself. And every problem is going to be different. So in this one, first of all, I'm going to try to get rid of that fraction. So to do that, I will multiply every single term by the denominator of that fraction. So everything by 2. Yeah, whatever the denominator of the fraction is. Because in my fraction, 2, that's a 2 over 1, right? That would be negative 2x squared over 2. Basically, that means your 2's are going to cancel, leave you with negative x squared. I know this is a mess. 2 times positive 2 is positive 4, equals 2 times negative 2x, or I'm sorry, 2 times negative x is negative 2x. 2 times negative 10 is negative 20. If I combine like terms, I'm going to have a quadratic term, a constant, and a linear term. So it's not like I can just solve for x real easy. So I'm going to try to get everything on one side of the equation, set it equal to 0, factor it, and then solve it. Of course, they didn't give us a multiple choice on this one, so we couldn't even try to look at our options and plug stuff in, right? We actually have to do it the long way. So since x squared is negative and it's going to be my leading term, I'm going to take it to the right side to make it positive. And I'm going to move the 4 over as well. So that leaves me with 0 equals x squared. There's nothing to combine it with, so just x squared. In standard form, my next term would be minus 2x. And then I can combine these constants to make negative 24.
And then that's the answer.
No, I got to solve for x.
OMG.
So I'm going to try to factor. Hopefully I can factor and not have to do the quadratic formula. What is a?
X squared 1.
1. What is b? Negative 2. It's coefficient of the linear term.
C is negative 24.
C is negative 24. So remember, I need two numbers
And you eat negative
that multiply together to give you a times c.
Negative
1. A is 1. That's a comma. Negative 24. And you need two numbers that add together to give you b, which is negative 2. What do you think? Negative 6 and 4? Negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. That works.
That was only.
You did so good. I'm
So in my parentheses, the variable is x. Look in your T-chart to see what numbers to use. A minus 6 and a plus 4. Once I know my... Oh, what do I divide and slide by?
That thing is 1.
1. So in this case, if I divide by 1, is that going to change anything?
No, it's gonna be six.
No, but remember, if a was any other number, I have to remember to divide or slide. So what do I do to find my solutions once I've factored?
You do x minus 6 equals 0, and then x plus 4 equals 0, and then turn 6 into a positive.
All right.
And this would be
Bless you.
Bless you.
So set each factor equal to 0, and then solve for x.
So x is going to be positive 6 and 1. X is equal to negative 4.
So I have two values for x. That means that my parabola and line are going to intersect in two places. They're going to intersect at 6 comma something, and they're going to intersect at negative 4 comma something. To find that ordered pair, if I want to find 6 comma whatever, I'll plug 6 back into either equation for x, which I can just do it in my head. I'll just pick the easier one. I'll pick y equals negative x minus 10. So that would be y equals negative 6 minus 10, which is negative 16. If I plug in negative 4 for x, that would be a negative negative 4, which makes a positive 4 minus 10, which is negative 6. And to answer the question, we really don't even have to do that, because the question said, what is the greater of the x coordinates of the points of intersection? These are the x coordinates where they intersect. Which one has the greater x coordinate?
Negative 6 and then
It
negative
wants to know the greater x coordinate. 6.
negative 16.
So my answer is 6
For question 4.
for question 4. The answer is 6.
That's a lot for one problem.
Well, if you only have 19 problems, you got time, right? So on the review, there's only 19. Usually, like I said, the test is very similar, so they haven't told us how many, but probably about the same.
We're going to have 18.
Maybe. I mean, 20 seems logical, but who knows? Number 5. What are the solutions? What are the solutions of the systems of equations? Okay, we're doing the same thing we did in number 4. We're still finding the solutions, except for on number 4, it just wanted to know which one had the greater x value. Number 5, we're going to find the whole solution. Like, I ended up finding the whole solution for number 4. I didn't have to. That was more than necessary. I just needed to know which had the greater x value. But in number 5, I do need to know the actual solutions. So we're going to do the same thing. We're going to isolate the variables, either x or y, and then we're going to take the other half of the equation, set them equal to each other, okay, and solve for the variable. So in this case, look at the first one. It already has the y isolated. So if that much is done for me, would I want to rearrange this and isolate the x? No. Wouldn't make any sense. So if the y is already isolated in the top one, then I might as well isolate the y in the bottom one, because you can't have one with the x isolated and one with the y isolated. They're both x or they're both y. So I'm going to take this equation and I'm going to isolate my y. That means get the y all by itself. So what should I do?
Plus 1.
I can either subtract x or add y. It doesn't matter, right? I'm just going to subtract x. So I don't have y, I have minus y equals minus x minus 2. Then what?
Then you plug it in.
Have I isolated the y?
Yeah.
I gotta divide by -1, exactly. So y equals x plus 2. Yeah. So I'm going to take what y was equal to in that top equation, which was x squared minus 6x plus 8, and set it equal to what y is equal in this bottom equation, which is x plus 2. I can see I have quadratic terms and linear terms and a constant, so it's not like I can just move everything to one side and say x equals this. I'm going to have to get everything on one side and then hopefully solve by factoring, okay?
Is that an 8 in here?
Yeah. I'm getting my information from the problem. So since my term with the highest degree is on the left side and it's positive, I'll just keep it there and I'll move the x and the 2 over to the left. So I'll subtract the x and I'll subtract the 2. So on the right side we've got 0. On the left side, combining like terms of x squared minus 7x plus 6. I've got a quadratic. Hopefully I can solve it by factoring. If not, I'll use the quadratic formula or completing the square.
A is 1, B is -7, C is 6.
Right, A is 1, B is -7, and C is 6. So in your T-chart,
You can do -1 times -6.
hold on, let me get my T-chart filled out. I need two numbers that multiply together to give me A times C. So 1 times positive 6 is positive 6. And you want them to add together to give you B, which is -7.
So -1 and -6.
All right, let's try it. -1 times -6 equals positive 6. -1 plus -6 equals -7. So in my factors, I have x minus 1 in one set and x minus 6 in the other set. What would I divide and slide by? 1. Is that necessary? No. Any other number and it would be. So now that I have my factors, I'll set my factors equal to 0. X equals 1. X equals 6. I'm looking for ordered pairs though. I want to know where this parabola And where this line, they're going to intersect at two places. I want to know the ordered pairs.
It's integrated.
So right now, if you look at the multiple choice, only one possibility has an x value of 6 and an x value of 1.
Because they're both positive.
But yeah, I mean, there's a 6 and a 1 for x, right? But we want to just double check. So at least let's plug it in and see, because the y value has to be true too. So if I plug in x equals 1, and you can plug it into either equation because it's where they both have the same ordered pair. So if I do x is 1, that's 1 minus y is negative 2. Subtract 1, that's negative y equals negative 3, so y would be positive 3. Does that work out?
Yeah.
Yeah. And if I plug in x is 6, bottom equation's easier. That'd be 6 minus y equals negative 2. Subtract 6, so you have negative y equals negative 8, which means positive y is positive 8. And that works as well, so B is your answer. If you forget all that and it's multiple choice, you can take each one of those ordered pairs and plug them into both equations and see which ones make both true for both ordered pairs. But that's about just as much work too. Julio? Lyman, bring me your phone, please. Alright, number 6. Of course I had to throw one with a bunch of crazy fractions in, but that's okay. What is the x value of the axis of symmetry of the parabola? Okay, we spent a lot of time on factoring quadratics, but it has been a while. Remember, a quadratic was when you have a squared plus b, ax squared plus bx equals c, where you have the quadratic term and then the linear term and the constant, right? And that makes a parabola, and you have a vertex in your parabola, right? So remember, and this is asking you about the vertex. To find the ordered pair of the vertex of a parabola, you always find the x value of the vertex first. And to do that, you do x equals opposite of b over 2a. This is only good for quadratics. So remember, a is 1/2, b is 3, and c is 13/2. Don't turn it into decimals, just deal with the fractions. And I'm finding the x value of the vertex first. So to find x, I do opposite of b, which if b was positive 3, the opposite of that will be negative 3 over 2 times a. So that's 2 times 1/2.
What did he say? 3?
Yeah. So we can simplify that. X equals negative 3 over, what's 2 times 1/2 means half of 2, which is what? 1. If you have $2 and I take half of it, now you got $1, right? So negative 3 over 1. So the x value of my vertex is negative 3. It only asks me for the x value of the vertex, but just in case it wants to know the whole vertex, once you know the x value of the vertex, to find the y value, you plug it in, right? So I'm going to say when f...
Pardon the interruption. Teachers, at this time, please release all Bartow and Summerlin seniors to the auditorium. All Bartow and Summerlin seniors to the auditorium, please. Thank you.
So I'm going to plug this in. That would give me, and I'm using the original function, so 1/2 times x squared, so x is negative 3 in this case, plus 3 times 1/2 plus 13/2. That's 1/2 times 9 plus 3 times 1/2. I'll come clean all this up. Plus 13/2. All right, so 1/2 of 9 is 4.5, but I'm just going to leave it as an improper. So I'll just do 9/2. Since they all have the same denominator, it'll be easier. Plus 3 times 1/2, again, it's 1.5, so I'll just do 3/2. And then plus 13/2. So since they all have the same denominator, I can just leave the denominator, add the numerators. So 13, right? So 9 plus 13 is 12. And 12 plus 13, I'm sorry, 9 plus 3 is 12. 12 plus 13 is 25. So 25 halves, which is what, 12.5? So my vertex would be -3, 12.5. But the question just said, what is the x value?
8.
Oh, I didn't even say vertex. OMG. What is the x value of the axis of symmetry? So that's the axis of symmetry is the line that goes through the vertex. The axis of symmetry has the same x value as the vertex, okay? So, my bad. Still, we found the answer is -3.
What does that say? Like the 9 over 2, 3 over 2?
13 over 2.
Yeah, but what's the one next to it? Equals what?
25 over 2. 9 plus 3 plus 13 is 25. So it wanted to know the x value of the axis of symmetry. It will have the same x value as the vertex. But I also gave you a quick little lesson in finding the vertex, which you did not ask at all. But we would find it the same way, regardless. Number 7, what is the minimum value of y equals 2x squared minus 8x plus 11? Again, we have a quadratic. The quadratic is going to open up, right? That means it will have a minimum. When it opens up, it has a lowest point on the graph. When it opens down, it has a high point. So when it asks the minimum, it's talking about the vertex. So we're going to have to find the vertex on this one again. It's a parabola. It's a quadratic function, which makes a parabola. The parabola is the shape. The type of function is a quadratic, so it has 2 degrees. So again, we're going to find the x value of the vertex first. X equals -b over 2a. We know a is 2, b is -8, and c is 11. You can see it wants the whole ordered pair. You have to find the x first. So to find the x, you do opposite of b, which b is a -8, so it'll be a +8, over 2 times a, so that'll be 2 times 2. So that gives me 8 divided by 4, which is 2. Notice every single A, B, C, or D, all of our options have an x value of 2. So we're going to have to find the y value, right? So when x is 2, what is y in this function? I take the function, and I want to know when x is 2, what is y? So wherever I see an x, I plug in a 2. So I have, well, make sure you do your order of operations correctly. Do not multiply 2 and 2 first. You got to do the exponent first. So 2 times 4. Then I'll take care of this multiplication. So I have y equals 8 minus 16 plus 11. When I have addition and subtraction, I work from left to right. 8 minus 16 is -8. Plus 11 is 3. So when x is 2, y is 3. My ordered pair is 2, 3. Yes, it would be C. Everybody good? Okay, 8 is worded kind of weird. It says given function A is f of x equals x squared. So that's our function A. And coordinates for B function are given in the table. So they gave us the actual function for A. And B, they didn't like give it to us written like as an equation. They just showed us what the ordered pairs were. Okay? So this function and this function are two different functions. What is the value of the function that has the greater y coordinate when x is 3? Okay? So what I did was I said, okay, function A, I evaluated it when x is 3. So f of 3 equals 3 squared. And 3 squared is 9. So in function A, when x is 3, y is 9. Okay? So we have to figure out, this is function B down here. This is function B. Notice we got to find a pattern. X is 0, 1, 2. So we know our next x value is going to be 3, right? Look at your y values. As x increases by 1, what are your y's doing to get to the next term in the pattern? Doubling. Because 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So in function A, when x is 3, y is 9. In function B, when x is 3, y is 8. The question said, what is the value of the function that has the greater y coordinate when x is 3? Which one's greater? When y is 9 or when y is 8? Because x is 3 on both of them.
Y is 9.
When y is 9. So your answer, and it was not a multiple choice, is 9. So if you see one like that, like again, I mean, it's kind of confusing the way it's worded. It's simple to find the answer. It's just the way it's worded, it's kind of weird. But if it's on the review, it's likely to be on that test. Am I right? Yep. You know it. Number 9, consider the equation x squared plus y squared minus 2x plus 8y plus 13 equals 0. What is the center and radius of the circle? Okay. This was the next video that we were going to do today, but I wanted to get the review in. So I can post the video that I have ready to do this. It's about circles. You know, we've done the last 2 classes on circles. We did circles centered around the origin. And we did circles centered at h, k. And all of those circles, the circle centered around the origin was x squared plus y squared equals r squared. And then circles centered around h, k was x minus h quantity squared plus y minus k quantity squared equals r squared, right? This is a circle, and I know it because it's got an x squared and a y squared, and then an x and a y. So I know it's a circle. It's written in what's called general form. Okay? You know what I want to do? I'll skip this one now, and I'll go on to the others, and then I'll teach you the lesson next class on this. Otherwise, it's going to take me 40 minutes to explain this one problem. And then 10 is the same thing. 10 will come back to because they both pertain to the same lesson. All right? So they both will, no. Once I teach the lesson, we can answer them easily, but I don't want to, I want to make sure I get through everything else, and we'll come back to it, okay? And if not, I'll post the video. Y'all can watch it on your own if it comes to that. So we'll move on to 11. Line M is represented by the equation 2x plus 4y equals 12. Which of the following equations represents a line perpendicular to line M and intersects line M at its y-intercept? This is total geometry question. Y'all learn how to do this in geometry. It might have been a while, but hopefully when I remind you, you're like, oh yeah. If 2 lines are parallel, they have the exact same slope, right? Because if they have the same slope, they're increasing, their like rise over run is increasing at the same rate. So they're never going to cross paths. If two lines are perpendicular, that means they meet at a 90-degree angle, then their slopes are going to be negative reciprocals of each other. So you're going to have one positive and one negative. Y'all remember what a reciprocal is? It's when y'all want to say flip, but that's not really a math word. But your numerator becomes the denominator and the denominator comes to the numerator, right? So what's the reciprocal of 3 over 2? 2 over 3. If I said what's the negative reciprocal, you would say negative 2 over 3. One's got to be positive, one's got to be negative. If it starts negative, what's the negative reciprocal of negative 1/2? Positive 2 over 1. Flip these. One's got to be negative, one's got to be positive. If it starts negative, then the negative reciprocal is going to be a positive. Okay? They can't both be negative, they can't both be positive, or they won't make a 90-degree angle when they intersect. Does that make sense? Alright, so they're telling you that line M is 2x plus 4y equals 12. This is line M. And if I want to know about when it's going to be perpendicular to some other line, I got to figure out what its slope is, because slope is what tells me if they're going to be perpendicular or not. Okay? So it's currently in standard form. I want to put it in slope-intercept form, which is y equals mx plus b. So I got to isolate the y, and then whatever the coefficient of x is, that's my y-intercept. Y'all kind of remember that from geometry?
No.
So to isolate the y, the first thing I would do is subtract 2x. And I get 4y equals negative 2x plus 12. And then I'm going to divide every term by 4. So y equals, instead of negative 2/4 x, I can reduce that to negative 1/2 x. And then instead of plus 12/4, it'll be plus 3. So line M has a slope of negative 1/2 and a y-intercept of positive 3. That means it's going to cross the x-axis at positive 3 and a slope of negative 1/2. So if I go up 1 to make it negative, I have to go to the left 2. If I go down 1, I have to go to the right 2. So that's my line M. I want a line that's perpendicular to it. Not only does it have to be perpendicular, it says which of the following equations represents a line perpendicular to line M and intersects at the intercept. So it's got to be perpendicular and it's got to cross at the y-intercept. So basically, one of these equations has to have a slope. Since this slope is negative 1/2, the negative reciprocal would be positive 2 over 1, which is positive 2. And we want them both to cross at the y-intercept of 3. So I'm looking for an equation that's y equals 2x plus 3. All of these are in standard form. So I'm going to convert them all to slope-intercept form until I find which one.
Let's just make an H equal against it. See.
Nope. So let me look at A. Negative 2x plus y equals 3. I'm going to put it in slope-intercept form so I can easily see the slope and the y-intercept. So I will add 2x to both sides. And I got y equals 2x plus 3. Are the slopes negative reciprocals of each other? So 1 over 2, this is 2 over 1. It's one positive and one negative. Yes. Do they both have the same y-intercept? I already found my answer.
Hey, I told you to.
Me personally, I did every single one of them just to double check, because you know sometimes you'll find like you'll do all 4 and then you'll like wait, no, this is the answer, and you'll realize there's a mistake somewhere. So I did all 4, but it's A. I've already done it.
Majority I told you it was A, but you wouldn't believe me.
Okay.
No, that was you said.
Number 12, the imaginary number I can be defined mathematically as I squared equals negative 1. Y'all already know this. What is the value of I to the 13th power? So, if you just think about it logically, you can do this much easier, but me, I take the long way around everything, of course. So, I wrote I to the 13th out. I did I times I times I times I 13 times. That's what I'm going to do right now.
Doing it 13 times.
Jose, hush. One, Jose, hush. So I've got 13 I's there. That means out of the 13th because I multiplied them all together. I squared is -1. Y'all remember when we learned complex numbers and imaginary numbers? Whenever you had an I square, you had to replace it with -1. Well, what is I times I? I square, which is -1. So this is what I did. I said, okay, well, I times I, that's going to give me a -1 there. That's going to give me a -1 there. -1. -1. -1. You got to make sure you stay organized. And I got one I left over. So now I'm -1 times -1 times -1 times -1 times -1 times -1 times I. What's a -1 times a -1? Positive 1. And I said, what's a positive 1 times -1? -1. What's a -1 times -1? Positive 1. Positive 1 times -1. -1. -1 times -1. Positive 1. Times I. What's 1 times I? I. All of that is I. Which is option C.
I told you, when you educating kids, you should see this.
I'm sure. I'm not much of the shortcuts. That wasn't difficult, was it? Number 13. Which expression is equivalent to negative square root of 4? Hey, let me break this down. Is there gonna be an I in negative square root of 4? Is there a negative under the radical? No, so be careful with that. Minus the square root of -9. Well, I have an I when I simplify.
Yes.
Yeah. So this negative and this negative are different. If it's under the radical, that's when you get an imaginary number. If it's not, there's no imaginary number.
It's either A or B.
So what's the square root of 4? 2 times the negative is -2. There's no I's here. There was no negative under the radical. Minus, what's the square root of -9? No. Minus 3I. There's a negative under the radical. So this minus is this minus. The I is because there's a negative under the radical.
It's A.
Can I add those together or subtract them?
No.
No, they're not like terms. I've got a real part and an imaginary part. So it is A.
14.
Very good. 14. How many solutions does the quadratic equation have? Well, we can try to factor and we'll figure out how many solutions we have, but if it's not factorable, we got to do the quadratic formula or completing the square. So I always like to try to factor if I can. It's a quadratic. Quadratic's factorable. Not always, but sometimes. A is 1. B is 4. C is 8. I need two numbers that multiply together to give me A times C. That's positive 8. And add to give me B, which is positive 4.
Negative 2 times 4.
Negative 2 times 4 is negative 8. That's not going to work. What else? Let's see. 4 times 2 is 8. What's 4 plus 2? That's not going to work. How about 1 times 8 is 8? What's 1 plus 8?
9.
That's not going to work. What if I did -1 and -8? Would that work?
No.
-4 and -2. Positive 2 and positive 4.
No.
Same thing. I already did that. Are there any other factors of 8?
No.
No. So does that mean we can't answer the question?
Yes.
No, it just means we can't answer it by factoring. So I'm going to use the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. And I'm still using the same a, b, and c, right? It doesn't want to know what the solutions are. It wants to know how many and what kind they are. So x equals the opposite of b. That would be -4 plus or minus the square root of 4 squared minus 4 times 1 times 8 all over 2 times 1.
So 4 times 4 is 16.
Yup.
Then 4 times 1 equals -4.
-4 times 8 is
-32.
-32. So that's going to be -4 plus or minus the square root of -16 over 2. I know right now, I'd have to keep going to know exactly what my solutions are, but if I just want to know what kind of solutions I'm going to have, what kind am I going to have? How many complex? 2. Because this is going to be -4 plus or minus 4i all over 2, right? So that's going to give me 2 complex solutions. Complex means it has an imaginary part in there. So 2 complex solutions. So you can't say no solutions. There's just no real solutions, but they're solutions. They're just imaginary. So be careful about that. 15. What are the complex zeros? So we already know we're going to have some imaginary stuff in there. For x squared minus 2x plus 10 equals 0, consider the quadratic formula. They're trying to tell you don't waste your time with factoring because you can't factor it. Okay? And it actually wants to know the answer, so we got to go all the way through. So what is A? 1. B is -2, and C is 10. X equals -b plus or minus square root b squared minus 4ac all over 2a. Yeah. So what's the opposite of b? Positive 2 plus or minus whatever b is, square it. So you got to make sure you square that negative. Minus 4 times 1 times 10 all over 2 times 1. So we have x equals 2 plus or minus -2 quantity squared is 4. And then -4 times 1 times 10 is negative 40, right?
Yeah.
All over 2. So x equals 2 plus or minus, what is 4 minus 40? -36. What kind of solutions are we going to have? 2 complex, right? We haven't found them yet. What is the square root of -36? 6i. So 2 plus or minus 6i all over 2. Will I reduce that? Can I reduce that if I separate it? Yeah, because 2 divided by 2, that'll reduce. And then plus or minus 6i divided by 2, that'll reduce. So what's 2 divided by 2? Do we have to include that? If I'm multiplying by 1, I don't. If I'm adding a 1 or subtracting, I do. So 1 plus or minus what?
6.
What is 6i divided by 2?
2.
3I, which is option C.
You hear Alan here?
What's that?
Alan said, maybe we should listen to him, like, sing every time.
Alright, so for today, I will stop at 15. We got to go back and get those two others. Plus, we got to do 16, 17, 18, 19 next class. I'm going to go ahead and pause this. So look for video 2 if you're absent.